Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is another permutation of the same problem, and I want to make a little twist. So see, when I'm making twist and solution a little bit different, you should feel more comfortable in understanding the whole problem and the whole situation, and coming from different points and having the same results serve us as assurance that we're doing everything correctly. It's like in math, you obtain the roots and you plug it in the initial equation and validate that everything is fine. So what I'm trying to say here is that this is perfect and the most easiest solution, I think. But we can solve it a little bit differently. We can say that we have u, which is 2, and we have v, which is longer than that, and we can add those two vectors. And remember, and if you don't remember, go to my playlist vectors. It's a very simple playlist, but you have to be comfortable as a prerequisite for vectors, for physics. No deep math, but simple rule. You move this here, and you obtain this as a vector. This vector u plus v, vectors, and those are vectors. Here I dealt with projections of the vector. The moment I am dealing with projections, it's like a number. This is number and this is number. Here, vector is the length of the vector and its orientation. And remember, this was triangular rule. You put this here and you connect like this. Or there is also a parallelogram. You build a parallelogram here and put a diagonal, and this is absolutely the same. This is u plus v. Alright, so let's denote it then as alpha, and we can basically write a couple simple things. We can say that this is u, the length in this triangular. This is u, this is v. So the length of this vector, would be square root of u squared plus v squared. This is a Pythagoras theorem. This is u, this is v. Once again, this is v, this is u. No vectors. This is a triangle. And this length would be u squared plus v squared, and we have extract square root. And this is exactly what it is here. Right? And this is the first thing that I will notice, that this is the total speed, and total speed is this, its value. Now I will come here and I will say that this is d, and this is l, and this is the same triangle, and it is the same alpha. And if this is d and l, there is no vectors. This is d squared plus l squared. And this is square root. Okay. And then I can say the time for crossing would be this distance, square root of d squared plus l squared, divided on this speed, because they're all allocated along the same line. This is one-dimensional movement along this line. We presented it here as two independent linear movements in this way and this way with constant speed, but in reality, if we're sitting in the boat, we're moving like this along the shore, and time would be that. And here we have to do a little trickery. We have to use that this alpha is the same. And how we define the alpha? And we define the alpha, for instance, from here. This is L over D is tangent alpha. And if we look on this situation, this is the same alpha, it would be V over U. This is definition of a tangent. Please refer to vector playlist. Please refer to geometry playlist. I talk about those little things in detail. And so we have this, so I can write here L equals D tangent alpha. This here, and I can say U equals V tangent alpha. And if I plug those L and U here, I will have square root of d squared, and instead of L I type plus d squared tangent squared alpha. And if I go on the bottom, I type U is V tangent alpha, so square root is V squared tangent alpha plus V squared. And this would be square root equals. And I don't have time, I don't have room, so let me write, for example, here. Because I want to keep this maybe for the next solution, next implementation. So I will have here, I continue, I will say that here I can factor out square root of d squared, and it will be 1 plus tangent squared alpha. I take d squared out, and inside of bracket I have 1 and tangent squared. So if I multiply this, I will receive d squared plus d squared tangent squared. And on the bottom, I do the same thing, but I factor out v squared. I factor out v squared, and I receive tangent square alpha plus 1, which is essentially the same like this. So those goes away, and what I left, square root of d squared was d, and square root of v squared is v, and I receive time, which is exactly like this, d over v. And basically that shows us nothing except of second way of solving the same problem using like real one-dimensional movement, versus here it's a two-dimensional movement. And I hope this will be interesting for you to observe. And if you liked it, like. If you want more, because there would be next implementation of this similar problem, subscribe bell not to waste time and be notified when I publish. Question, problem, thank you.